You've probably learned about geometric series before. It's when you multiply. My definition of a geometric series is as follows. I have some series, remember series as a sum, of a times r to the n, which is the same as a plus ar plus ar squared plus ar cubed, all the way up, as long as a doesn't equal 0. And we call r is what we call the ratio. So of course r doesn't equal 0 as well. So think about it. If I multiply by a number, if the absolute value of r is less than between 0 and 1, or is less than 1, then so if r is between -1 and 1, not equal to 1, every time I raise it to a power, it's going to get smaller. So that for this, if that's true, then as n goes to infinity, r to the n goes to 0. So that means it converges, and I can actually define that sum. So the infinite sum, it's s. Sometimes we call s or s. And it is the sum as n is 0 to infinity of ar to the n, which is the same as a over 1 minus r. And this is a very powerful term. We're going to be using that later. So now I want to talk about some properties of infinite series. So what I need to do some definitions here. So I'm going to let the sum of an and the sum of bn be convergent. And I'm going to let a, b, and c be real numbers. So if I have the sum of an equals a and the sum of bn equals b, then I can then the following converge. As well, because a and b converge. So the first one is the sum as n equals 1 to infinity of c times a n, and that's going to equal c times the convergence for the sum of a sub n. And then the sum n equals 1 to infinity of the two series together is the sum of the two, each of the two series alone. And again, same difference, same idea. If I do look at the difference, it's the difference of the two sums. I have the nth term test for divergence, and it looks like this. It says if the sum as n equals 1 to infinity of a sub n converges, then I know then the limit as n goes to infinity of my terms should equal 0. So they're going to 0. Think about it. As if an gets smaller, eventually you're not adding anything else to the sum, so it will converge. So therefore, thinking about this, if the limit of my nth term is not 0, then I know that my sum, my series, will diverge.